Yeah, good evening, student. How are you? So, is there any problem with your school? Are you have joined with the projector or you are individually joined? Tell me in the chat box if it is so. So, here we are with our lecture number 2 on simple harmonic motion. Okay. In the very first lecture, not so much topics will not be covered. So, we will cover them, revise them firstly, and then we will move on to the next topics. So, firstly, so in this, the entire chapter includes the periodic and oscillatory motion, simple harmonic motion, and discussion of mainly go around this simple harmonic motion only. Okay, we will discuss about the kinematics of it, and then we will plot the graph relating various physical quantities with each other. Then also we will also relate it with the uniform circular motion. Okay. After that, system exhibiting SHM that we also include like simple pendulum, okay, and physical pendulums also. Then damped oscillation and forced oscillation. This is not the a very vast topic, but a single information is being conveyed to by these topics. Okay, the entire discussion on this topic in a thoroughly way will be discussed in your higher order classes. So if I talk about the yesterday's or the previous session that we have covered, we have mainly talked about the periodic motion and oscillatory motion, and some of the key term that is period and time period, basically frequency that we have discussed. Okay. So firstly, if I talk about periodic motion, what is periodic motion? That motion that repeat itself after a fixed interval of time. That motion is termed as periodic motion. So we can say the motion which repeat itself after a fixed time interval. So that particular motion is termed as periodic motion. Okay. So various examples of relating to periodic motion, that is motion of our earth around the sun, that could be a periodic motion. Okay. And motion of your father going to office and coming back to home if they are coming to the same time. Okay, that is also considered to be a periodic motion. If they leave the house at 9 a.m and they come to the home at 7 p.m daily, on the daily basis, so you can conclude that motion also in the category of periodic motion, because the time period, the time interval they are taking to repeat that motion is fixed. Okay, so that you can take the example. For example, we can say motion of earth, motion of earth, and yeah, obviously circular motion you can also consider to be a uniform circular motion. Uniform circular motion is also considered to be a periodic motion. Okay, now this you can see here the main difference between circular and oscillatory motion. So what is an oscillatory motion? If I talk about oscillatory motion, is also a kind of repeated motion, but the oscillatory motion is bound with some point, and that point is termed as a mean position. We'll write it as oscillatory. Spelling may not be corrected, but it's fine. Oscillatory motion, if I talk about, this motion is also repeated motion. Okay, this motion is also repeated motion, but it is a bounded motion. It is bounded motion, which means the motion is repeating itself, but about a point. And that particular point is termed as mean position of that particular oscillatory motion. Okay. For example, if you will consider a spring block system here, if we release the or compress this block with some distance, let's say x, then what will happen? If we release it, it will go back to its original position, but due to the inertia of motion, because now by this time it has acquired some velocity, so it will cross its mean position, let's say this, and compresses the spring, then going back to this, then coming back to this. So these types of to and fro kind of motion is termed as oscillatory motion, but it is always a bounded motion, remember it, and it is bounded about a mean position. For example, also you can consider the motion of simple pendulum. If this is a bob tied with the string and you release it from this point, then it will go this way and this way, this way and this way. So what it trying to do, it wants to come back to this particular position, which is termed as mean position. When we will discuss the kinematics of SHM, you will get to know that what is the mean position, what the function of the mean position is. Okay. So if you talk about the oscillatory motion, the oscillatory motion mein body moves about a mean position, but in periodic motion there is no mean position. Okay. At extreme position, at this extreme position, the velocity becomes zero. That we will discuss also in the kinematics. But in this, velocity never equals to zero. Okay. The direction of velocity will never reverse, but in this direction of velocity get reversed at the extreme point. Okay. So on the basis of that, we can conclude that all the types of motion, all the types of periodic motion are not oscillatory, because a motion to be oscillatory, we need a mean position. Okay. But because oscillatory motion is repeating itself with a fixed time interval, so it clarify or is justify the category of periodic motion. So we can say that all the oscillatory motion are periodic motion, but vice versa is not true. Or opposite is not true, which means all the periodic motion is not oscillatory, but all the oscillatory motion is periodic motion. Okay, this is the important statement. Now, if I talk about the period, frequency, and displacement. So what is the period? Period is that time interval in which the motion is get repeating itself. Okay. The time that a particular body which executing the periodic motion, the time that it will take to complete one revolution or one step of this repeated motion is termed as the time period. If I talk about, for example, the earth which is rotating about the sun. Okay, this is also a periodic motion because our earth is repeating constantly. Okay, continuously, and with a fixed time interval also. So that particular motion will justify the category of periodic motion. So if I talk about what the period of the earth rotation or what the period of earth periodic motion, so our earth completes its one revolution in 1 year approximately. Yeah, definitely, very good. So 365 days are the of time period for earth revolution, or you can say it is the time period for periodic motion of earth. Yeah. Now, to the smallest interval of time after which the motion is repeated, that particular time is termed as time period, and SI unit is second. So if I talk about the time period of minute hand, so minute hand will repeat its motion about 1 hour. After 1 hour, it will again go back to 12 if it is starting from 12. So about exactly 1 hour, it will go to 12. Okay. But if I talk about the time period of second hand, what is that? Please answer it as soon as possible. And also the or hand. Yeah, 60 second is the time period for second hand because it is completing its motion, complete motion in 1 minute, or you can say 60 second. And for R hand, for R hand, yeah, it is 60 minute. Very good. Keep it up. So this is all about the periodic motion. Now, if I talk about the frequency, frequency is the number of oscillation or the number of event that has been happened in unit time. Okay, in 1 second, how many revolution it has covered, or how many times the motion has been or how many revolution it has been taken. That is the frequency. Frequency has been derived from frequent. Okay, how frequently the event is occurring, that is the frequency of that event. Okay, suppose you take 8 glasses of water in a day. So if I talk about the frequency of consuming water in a day, if I consider the time unit is 1 day, unit time is 1 day. So what is the frequency of consuming glasses of water? It is 8, because in 1 day you will consume 8 glasses of water. Got it? Same thing, if I talk about that one revolution of second hand, if I talk about, okay, second. So one revolution will take around 360 degree because it is rotating completely. Complete circle means 360 degree. So how many revolution it has been covered in 1 second? Because in 60 second, it is covering 360 degree, which is one revolution. So in 1 second, 360 upon 60, which is 6 degree per second. Okay. So that is the frequency of second hand, which is it is covering 6 degree. Matlab one revolution is 360 degree, or you can say 360 degree is one revolution in terms of revolution or rotation. So in 6 degree, how much revolution it has been taken? 1 upon 360 into 6. If you cancel it out, 1 by 60. So 1 by 60th revolution, it has been covered in 1 second. Okay. So that is the frequency. If you carefully notice it, the frequency that I have given is, let's say, inverse of time, because I have divided this expression with time. And the finally we got frequency. So we can say that frequency is the inverse of time. Okay. Revolution and all the things, I think it is clear to you. Now, if I go according to the definition wise, the frequency of the periodic motion, the number of oscillation or repetition occurring per unit time. Okay. So SI unit of it is hertz. Okay. And reciprocal of time period is given by this frequency. It is given by nu. It is nu. It is pronounced as nu. Okay. And somewhere it is also written as F. So F is also 1 by T. The unit of it will be hertz or second inverse. Got it? So minute hand key frequency you can calculate 1 by 360 100, 3600, sorry. Now, if I talk about the displacement, what is displacement? In general, what the perception of displacement in your mind, in every student, in the mind of every student, what is the perception about displacement? That it is the minimum minimum distance between 2 points. That definition you have learned, na? The shortest path is displacement. Yes or no? But this is not displacement actually. Okay, I'm not saying that you are incorrect, but you are half filled with this information. Okay. So the complete information about displacement is that displacement is a it is a function of time that measures the change in a physical quantity. Physical quantity with respect to time, because this is the function of time. So as the physical quantity changes its magnitude or changes its value with respect to time, that particular function is displacement. Okay. So if you talk about the displacement function that you have learned so far in your ninth, 10th, and 11th also, now you are also in 11th. So whatever the concept that you have learned about displacement, that is the displacement of position. Displacement of position. So in that case, position is the time function, because you got it. When we talk about the displacement, the minimum distance, we are changing the position of that particular object with respect to time. That's how it came into motion. Okay. If it is changing its position with respect to time. Now changing position with respect to time. So which means that position is somehow related to time. So here position is the function of time. And what I have said, that displacement is the function of time which measure the change in any physical quantity with respect to time. So here, what we have learned in terms of position, that position is a function of time which changes its value. So that is the displacement. Now, in the 12th class, you will learn that how the voltage rise in the capacitor, rise across the capacitor, we will say, across the capacitor. Capacitor is a device which is used to store the charge. Okay. Across the capacitor, that will also time bound. So we can say that it is the displacement of voltage. Okay. Here, voltage is the displacement function. Okay. We can also say the change of pressure is also change of pressure. Change of pressure with respect to time. Okay. So displacement is not strictly related to the only change in position or the minimum distances between 2 points. Displacement is related to each and every physical quantity which is a function of time, yeah, which varies the value of that particular physical quantity, if varies with time, that with associated somehow to displacement. Now I think it is clear to you. So from this chapter onward, do not make a rigid concept about displacement that it is only the minimum distance between two position 2 points, because displacement is the function of time. Got it? Now you can say change in position under consideration with time. So here in SHM also we will take this also, the position function of time. So here the change in position with time, which means that position is somehow related to time, or position is a time function or function of time. Okay, this one. If you talk, so as the time changes, the position of this block is changing. Okay, so here we can say the displacement of this block, the displacement is the block, is related to time. Got it? In this way also, in angular SHM, this, the change of angle is varying with time. So this is termed as the angular displacement. Angular displacement. And this is termed as linear displacement. Okay. Now, so if I talk about in the periodic motion or in SHM or in oscillatory motion, the position function or the displacement itself is periodic, which means displacement is also repeating its value after a fixed time interval. For that, you need to grasp this concept. Look, we have displaced it by B, okay, then it reaches to C. Again, it is coming back to B, and then it is going to C, which means here the displacement is also repeating its motion, repeating its value. So we can say here in the periodic motion, the displacement itself is periodic. Okay. So that is why function ft is periodic with time. The periodic function is written as ft is equals to ft plus capital T, and this is the time period. Time period. So the value of this function, if it is periodic, at time t plus capital T, and capital T is the time after which it repeats its value, it will be same as ft, the value of that function at small t. For example, sine theta is a periodic function. So if you talk about sine 30 degree, sine 30 degree is given by how much? 1 by 2. But if you talk about sine 150, okay, sine 150 is nothing but you can write it as sine 180 minus 30. This is also sine 30. Again, repeating its value. Okay. So the time period of sine theta will be 2 pi. So after every cycle of 2 pi, it repeats its value. Okay. And that is why we plot the graph of sine like this. So after this, you can say same curve will be from here. Okay. So that is why it is a periodic function, because it is repeating its value with a fixed time interval. And here the time period is given in terms of angle. So here the time period is 2 pi. Got it? Now, time period is given by t is equals to 2 pi by omega, where omega is the angular frequency, you can say, or the angular speed, both. Okay. So कोई भी function होगा, any function can be expressed as a superposition of sine and cosine function with different time period, angular frequency, and suitable coefficient. This one. So if you talk about sine omega t ko you can consider theta. So it is written as sine theta plus sine 2 theta plus sine 3 theta. Okay. So if sine theta is repeating its value after 2 pi, this 2 theta will repeat its value after 4 pi. This 3 theta will repeat its value after 6 pi. Okay. So which means when it has, when this, the biggest function completes one of its revolution at 6 pi, this function, this smaller function has covered 3 rotation then. 2 plus 2 plus 2. Got it? Now, in that kind of question, what you need to do, you need to take the LCM of each and every time period. Okay. So sine omega t has a period 2 pi by omega. We have seen already 2 pi by omega. So it is t naught. Cos omega t, 2 omega t here. So 2 pi upon 2 omega. Instead of omega, we have put 2 omega. So it is t naught by 2. If you talk about sine 4 omega t, so it is 2 pi by 4 omega, t naught by 4. So in the question, they will ask you what is the combined time period of this function. So you need to take the LCM in this. Okay. So LCM of this will come out to be t naught. So t naught is the time period of this complete function. Okay. But if you talk about this function, e raised to the power minus omega t, e raised to the power minus omega t is the non-periodic function, because at time passes, the value of e will increase and not repeat itself. So this is the non-periodic motion. Got it? Now, if I talk about the oscillatory motion, what is actually the oscillatory motion? So oscillatory motion is given by, it is given by a force displacement equation F is equals to k minus x raised to the power n. So this is the governing equation of oscillatory motion. And what is the oscillatory motion? Bounded motion. Bounded motion. Got it? Now, this is the oscillatory motion given by this governing equation. You can also write it as governing equation, where n will be equals to the odd multiples or odd integers. So n start from 1, 3, 5, 7, this. Okay. Now, so what is, we can extract from here, we can see if you put, take n is equals to 1. Yeah, that's why I'm talking about. That's what my next step, the how to use this equation. Now, this entire equation you don't need to use f is equals to minus k raised to the power n. Only the case when n is equals to 1 you need to use. Okay. So when n is equals to 1, so this force equation will become f is equals to minus kx. Here, if you talk about this k, this is the constant, not the spring constant. This is only a constant. But if we specifically talk about the spring mass system and observe its motion, then this k will become spring mass constant. Okay, spring constant. But here now, it is not the spring constant, it is just a constant. Now, if you will see here, if you will see here, Why we are taking the odd power only? If you put, if you observe this motion influenced by this force, so when this force is 0, when x is equals to 0. So this is termed as the, when f is equals to 0, this will come out to be the mean position. Because in oscillatory motion, we always has a bounded motion about mean position. So how to find the mean position? So for mean position, when the external force on the system will become 0, that position is termed as mean position. So here at x is equals to 0, this force function is becoming 0. So we can say that mean position is x is equals to 0. Now, if you are here in the positive side of it, and in oscillation, we always measure the distances from mean position. So if we are here, let's say x has some positive value, positive value. If you put x is equals to positive, here the f will be negative, because positive into negative will become negative. Force is negative, which means mass into acceleration according to Newton's law. Negative quantity is minus kx. So acceleration here will become minus k by m into x. Okay. Now, acceleration is negative, which means it is opposing the motion. When, so this will be in the direction like this. If acceleration is this direction, which means velocity in this direction. Okay. So this acceleration is opposing the motion, or in other word, you can say when x is equals to negative, for any negative value, the force here will become, tell me, what is the value of force will become? Either it is positive or negative. When we put x is equals to negative, for any power of this, not specifically one, for any of the power, tell me, either it is negative or positive. Yeah, definitely it is positive, because odd power of any negative number will give you, will come out as negative as it is. Okay, so negative come out as it is when the power is odd. But if the power is what? If the power is even, then it will come out to be positive. So here in this equation, it is minus k minus x. So it will become positive. Okay. So here the force will become positive, which means acceleration is now acting in this direction. So from this, you can conclude one thing, that in oscillatory motion, the force is acting in such a way that it always try to grab the object in mean position, at mean position. Look, what this acceleration want to do? Acceleration want to do that anything which is going in this direction, it wants to extract it into the opposite direction. Here, if you talk about in this way, the body is going in this direction, but this acceleration wants this body to be going at mean position. So that particular force is termed as the restoring force. So here, if you talk about this force is nothing but the restoring force. Restoring force, which wants to restore its value again, restore the system. Okay. For example, if this is the bowl, let's say, and here you have a metal ball, if you displace it here and leave it, what it will happen? What will happen to this ball? This will again come to this position. If you displace it here, it will want to again come back to this position. So this kind of motion is also oscillatory motion, because in oscillatory motion, the body or the force that is acting in that system always try to capture that particular body at mean position. Always try to pull that body on the mean position. Got it? Now, when x is equal n is equals to 1 in this equation, that case we have only discussed in the entire chapter. Only the case when n is equals to 1. So when n is equals to 1, that particular oscillatory motion is termed as simple, guess, simple harmonic motion. Okay. So in this governing equation, when n is equals to 1, the very first case of oscillatory motion, that will become simple harmonic motion. Got it? Now I think it is clear to you that how the simple harmonic motion has been derived. So simple harmonic motion is the simplest oscillatory motion also. Got it? Very good. Now, this you can say this is a kind of simple harmonic motion. Okay. One thing that I want to discuss, I will discuss it here. There are two types of SHM. The first one is the linear SHM, which is you are seeing on your screen. Linear SHM, in which the body travels in a straight line. And second one is the angular SHM. Angular SHM, the one that you have seen in the previous slide. Okay. So here if you will see, the body wants to capture this position, which is mean position. This position is also termed as equilibrium position. Okay. Now, we are going to discuss the kinematics of SHM. Okay. This will include that how we have derived this equation in the form of sinusoidal function and all. Here we are going to see what is the displacement, what is the velocity, and what is the acceleration of simple harmonic motion. So firstly, first thing first, the governing equation, if we write, it will become as F is equals to minus kx. Okay, for simple harmonic motion. Now, if you apply the Newton's law, apply Newton's law, second law basically. So this will become mass into acceleration minus k into x. So acceleration here will become minus k upon m into x. So acceleration is directly proportional to displacement, negative of displacement. So for every SHM or every oscillatory kind of motion, this equation need to be satisfied, which means that acceleration is directly proportional to the negative of displacement. Few pointers you will note here. Always measure the displacement from mean position. Okay, mean position. This is important. Now here it is satisfying our the relation that acceleration is directly proportional to negative of displacement. This is the condition for SHM. Okay. Now, if you talk about this, A is equals to minus k by m into x. A you can write as dv by dt is equals to minus k by m into x. Now, dv by dt again you can write dx by dt, v को we can write dx by dt, so it will become d by dt of dx by dt equals to minus k upon m into x. This will become d2x upon dt square is equals to minus k upon m into x. Now this equation, this is this is second order differential equation. Differential equation. Okay. If we solve this second order differential equation, which is not in your syllabus till now, and how we are deciding that it is first order or second order? Look, which order of derivative you have in the equation? We have d2, dt square. So it is 2. So this will be second order. If it is only dx by dt, so first order derivative. Okay. So first order differential equation will be there. Got it? So this is the second order differential equation in position and time, x and t. If you solve it, the solution of the solution of the same second order differential equation equals to x is equals to a sine omega t plus delta, and x is equals to a cos omega t plus delta. Okay. Do not wonder, do not worry that where where these sine and cos will come out, because if you solve this equation, that will be in your first semester, I think. Yeah, in your second semester of BTech, if you do BTech, in the second semester of that, you will be learning the engineering mathematics. In that, you will learn that how to solve these equations. Okay, so the solution of this equation will be a sine omega t plus s, a cos omega t plus delta. These are termed as harmonic, simple harmonic function, or you can say harmonic function. These are termed as harmonic function. And we are using it in the very first case of oscillatory motion, which is simple. So we can say that that motion is termed as simple harmonic motion. Got it? So these are the displacement equation. Now I will also tell you what is the difference between this and this. Okay. Now, if anyone has any, you have any kind of doubt in this, you can ask me right now. In this discussion, any kind of doubt if you will have, you can ask me right now. Okay. But obviously, if you are going to ask me the solution of this, I will not going to do that because it is not in your syllabus. It's just a waste of time for now. Okay. So this is it for today. I think the class timing has been gone up. So rest of the lecture we will discuss in the next class, in which we will discuss that what is the velocity function with respect to time. Okay. In this way, x is equals to a sine omega t plus delta. So what will be v? V is equals to somehow a omega sine omega t plus delta, and how it is come. Then we will relate the velocity with displacement only. Okay. Then we will plot the graph between, we can say, the displacement graph and time graph. So that we are going to do in the next class. Also, we are going to see the energy equation. Okay. And maybe two lectures will be required to complete some of this. Okay. So I hope you find this good. Any kind of doubt you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive, and tell your friends to be attentive in the lectures. Okay. Are you the classmate of Shiva? Okay. So which from which JNV do you belong?